Good day, everyone. So, today I will be discussing one of the searching algorithms used for sorted arrays, and this is the jump search algorithm. So, in this report, I will explain what jump search is, how it works through visualization, its efficiency, the pseudocode behind it, and a sample code demonstration. So if you're now ready to listen, let's now go to the next slide. So let's define jump search. So jump search is a searching algorithm for sorted arrays. So unlike a linear search that checks every element one by one, jump search moves ahead by skipping a fix of steps or jump. So the basic idea is to check fewer elements than linear search by jumping ahead by fixed steps or skipping some elements in place of searching all elements. So the basic idea for this, or the simple idea for this, is instead of checking all the elements, the algorithm jumps forward by a certain block size. Okay, so usually the square root of the array length. So once it jumps past the possible position of the target value, it performs a simple linear search inside that block. Okay, so this makes jump search faster than linear search, but still simpler to implement than binary search. So this is the algorithm. So for step one, calculate first the jump size. Then step two, uh, jump from index I to index I plus jump. Okay, so for the first step is we choose a jump size. So which is usually the square root of the array size. Then after that at the we start at the first element. Okay, and then we jump ahead using that block size. And then we just keep jumping until we land on the value that is greater than or equal to the target. Okay, so when we land on that value, this means our target, if it exists, must be inside the previous block. So for the step 3, if x is equal to the array I plus jump, then it will return x. Else, if not, then it will jump back a step. So for the last step is to perform linear search. So we do a linear search within a specific block to find the exact position. Now if the value is found, then we return the index, of course. But if not, the algorithm ends and return that the element is not present. So this combination of jumping and scanning makes jump search more efficient than checking every element. Okay, let's now go to the next slide. So assume the following sorted array. So example, this is just an example of array. So we have here 16 elements, then we will try to search or find for 77. Okay, so the first step is to calculate the size of the array. So the size of the array is, of course, obviously 16. So the jump size is the square root of n. So our n here is 16. So we will try to get this square root of 16, which is 4. So the jump size is 4. Okay, so since we have a jump size of 4, then we will search first for index search. Will search from index 0. Then we'll try to compare the index value. So the index value from this is 0. So we'll compare this with search number. So our search number is 77. So obviously 0 is less than 77. Then we'll try to jump from index 0, 1, 2, 3. Okay, so the index value, the next index value is 2. Okay, we jump from index 0 to index 3. So this here, 2 is still less than 77, and this is not the number that we are looking for. So let's try to jump again, 1, 2, 3. So the next value or the next index value is 8. So from index 3 to index 6. So let's compare the index value with search number. So 8 is less than 77. So still not the number that we're looking for. So let's try to jump again. 1, 2, and 3. So the next index value is 34. 34 is still less than 77. Okay, next from 34 to from index 9 to index 12, 1, 2, and 3. So let's compare. So this time 89 is greater than 77. So in this case, what are we going to do? We're going to do is to what we're going to do is to jump back a step. So if we jump back a step from 89 to 77. So this performs what? Perform linear search. So let's compare. So what we found here is 77. So this is now the number that we are looking for. So this is at index 11. So that's how we're going to search a value. Now let's talk about the efficiency of the jump search algorithm. So jump search sits in between linear search and binary search in terms of speed. It's faster than linear search because it doesn't check every element one by one. It skips ahead by using, again, jumps. So, however, it's a little slower than binary search because it still uses some linear scanning in the final step. Okay, so the time complexity for jump search is O of square root of n. So that is in the average case. So for the best case is O of 1. So the best case happens when the first element value we check is already at the target. So for example, if you are searching for the first element of the array, then the algorithm finds it immediately. So that gives us the best case time complexity of O of 1 or constant time. So for the average case, on average, a jump search needs about the square root of n. So jumps to locate the block where the element might be. Okay, so once it finds the block, then the linear search inside that block also take up to the square root of n step. So when you combine the jump phase and the linear phase, they both take around the square root of n steps. So that's why the average complexity of the average complexity is O of the square root of n. But for the worst case, it also occurs when the algorithm has to jump several times and then scan through a block, then usually when the value is at the very last part of the array, or the value is not in the array at all. So even in this situation, the total number of operations still stays around the square root of n. So which gives us a worst case time of O of the square root of n. So let's talk about the space complexity. So for jump search is also memory efficient. Okay, so because it only uses a few extra variables. So usually for the jump size and block boundaries, so its space complexity is O of 1 or constant space. Okay, so it's more efficient than linear search. Okay, so simpler than binary search and works best when the data set is sorted and allow a random access through indexing. So this makes it a practical option in situation where we want speed but still I need straightforward algorithm. Okay, so let us now go to the next slide. Okay, now let me explain the jump search code shown on the screen. So the function name is obviously jump search and it accepts two inputs. So the first one is the array or the sorted array and next is val. So the value, this is the value we want to search, the val. So right at the beginning, this program calculates the jump size using the square root of the array's length. So this jump size tells us how far we should skip ahead each time. Okay, then next, two variables are created. So we have here right, left and right. So these two mark the range or the block where the target value might be located. At first, we start at the very beginning, so both are set to 0. Okay, so after that, we enter the jumping phase. So this is where the algorithm gets its name, which is jump search. So the while loop continues jumping as long as we haven't reached the end of the array and the current value is less than or equal to our target. Okay, so inside the loop, the right boundary of the current block is computed by adding the jump size. Now, if the value we're searching for if the value we're searching for falls within this block, the jumping stops. But if it's not in the block, we jump again by adding the jump size to left. So if the value we're searching for falls within this block, meaning the array left is less than or equal to value and array right is greater than or equal to val, the jumping stops. Okay, but if it's not in the block, we jump again by adding the jump size to left. Okay, so what will happen now after the jumping stage? So after the jumping stage, the code checks if we jump too far or if the target value is already smaller than the first value in the block. So if any of those happen, it means the value is not in the array and the function returns -1. Okay, if the correct block is found, the algorithm switches to a simple linear search. So the loop checks every element from left to right. So if one of these elements matches the value we're searching for, then the function returns the index. Okay, so for the final output, if the algorithm reaches the end of the block without finding anything, then it will return negative 1. So this means the value does not exist in the array. Okay, so overall, so this code shows the two main phases of jump search. So again, first, it jumps through the array in big steps to quickly find the possible block. Then second, perform a linear search within the block to find the exact position. So that makes jump search faster than linear search while still being easy to implement. Okay, so in summary, jump search is a simple yet efficient searching algorithm that combines the idea of skipping elements and scanning only section of the array. So it performs well on sorted arrays and it is faster than linear search while still being easy to implement. Okay, so that ends my presentation. Thank you, and I'm still open to any question. Thank you so much for listening.